In this video, we're going to be discussing sharding and replication. And in the beginning of this course, we discussed something called horizontal scalability. And that's another big term which actually has the same meaning as sharding. But let's start off by asking a simple question. How many servers do you think Google has? Meaning, if we put all the servers that Google owns, the search engine, the maps, Google Docs, Google Drive, what else? Google Street View, all their GPS information. How many servers do you think Google has? And usually when I ask this in my on-campus class, I get 500,000, a million. Some people have said 10 million. And when Google started in 1997, it went online. By 2003, 6 years later, it had 10,000 servers. In 2011, it had 900,000 servers. 2012, 1.7 million servers. And it was estimated by the end of 2014 they would have 2%, more than 2% of all servers running on planet Earth, which was 2.37 million servers. We don't have a new and current estimate at this point. But you can imagine these servers require maintenance. Obviously, hard drives only last approximately 36 months. So there's a whole team of people who just work on the hardware, not to mention the software of all of these servers. So it's quite a big task to manage all of these servers as well as all of the data on the servers. Now, big companies like Google are not common, but they're becoming more common in the sense that they have literally terabytes to petabytes worth of data. Data that needs to be searched quickly, but most likely can't even fit on a single computer. To get a petabyte worth of space, and a petabyte is 1,000 terabytes. And I know companies out there that have 2 and 3 petabytes worth of data, actual running data. So that is a ridiculous amount of data to manage. So how do they do it? Well, Google's the one who won't necessarily came up with non-relational databases and sharding, but they definitely pioneered a lot of techniques, and then Mongo took it and packaged it and made it public. But you can imagine just for the search engine, there's a lot of data. It's constantly getting updated. It's constantly changing, and it needs to be very quickly searched. If you go to Google and you type in something like full sail, there's a lot of different paid ads, the main campus, but then if you look across the top here, maps, images, news, videos, information like this. And again, we've all used Google. It's on any topic on the planet. Facebook, login. Anyway, there's a lot of data out there that needs to be compressed quickly, so it needs to be searched quickly. And on top of that, there's probably thousands of other people within that same second doing searches. So now we're talking high scalability, a database that needs to perform thousands of transactions per second, not for a burst, but ongoing, perhaps for hours, days, or even months. So how do we go ahead and maintain this? Well, two things. One, we came up, not me, but the industry came up with something called sharding, and then another thing called replication. And replication definitely came first, and sharding came second. But sharding is, for the most part, just a non-relational database thing. There are some experiments and there are some relational databases that will do it, but relational data doesn't lend itself well to sharding. Now let me go ahead and explain what I mean by this. Sharding is a method for distributing data across multiple machines. And what I mean is, let's say you have 1 million records, and that probably can easily fit on one machine. What happens when you get 10 million? Well, for performance reasons, if 10 times the people are querying it, you may want to put half on one machine and half on another. I mean, an actual physical server. And then when you go ahead and get 100 million, well, that may have to go across 5 servers because one server either doesn't have the space to handle it, or if there's the space to handle it, can't handle all the transactions. You can't have one server handling all the transactions. So you need to split up your data. We're going to go into detail in a moment. Replication, though, is something different. Replication is creating a mirror image of a database. So imagine you have one database and it has your data on it, and that has to be up. Something like, something like a Twitter, or maybe your banking system, or again, something that if it goes down, you no longer make money. So it has to be up. So what you do is you can go ahead and create a mirror. So every time you update the main server, the copy gets updated as well. So the two databases are identical mirrors of each other. And this can be done in either non-SQL or SQL, the mirror here, the replication. But what it does is it provides you a level of fault tolerance. What I mean is, what happens if there's a power surge and your main database goes out? Well, you can go ahead and take your mirror, replace it, and service can keep going because that data is up to date. You haven't lost any data. If you don't have that, then how long is it going to take you to find your latest SQL dump and restore it? And then how much data is lost between when the default occurred and your last SQL dump? So replication has a lot of benefits. The biggest one is the fault tolerance, meaning you're not going to lose your data. But let's go ahead and get more detailed into each of these. So here's an example of sharding. And the application could be any application, meaning it could be Python, it could be PHP, it could be, for all I know, Visual C, Basic, C#. It doesn't matter. It's any type of application. And down here are your databases. And basically, your application will talk to a driver. And a driver is just a way to have programs talk to each other. So in PHP, most likely you're using a PDO driver to talk to MySQL. There's a MongoDB driver to talk to MongoDB. There's a, let's see what else there. There's a Cassandra driver if you want to talk to a Cassandra database. Basically, every database has a driver to talk to it. That's kind of the bridge. But your application will talk through a driver to what's called a query router. And essentially, this is a machine that has Mongo installed, but it really doesn't need a lot of space. It's just a router. It routes your queries. But then here's what happens. Instead of putting all our data on one server, maybe we put 25% here, and the next 25% here, and 25%, and 25%. Well, we still have all our data. It's just split up among 4 different servers at the time. Again, I'm just looking at what said primary. Don't worry about the rest for now. So what happens is when you run a query, like when you run a find, it's going to go through your driver to your query router. Your query router knows that which data ranges, basically, are on each of these servers. So it'll go ahead and say, let's say we need something that's going to, you're just going to query by last name. And we know for a fact that you're querying for Smith, and all the Smiths are on shard 3. It'll go ahead and route your query here, get all the Smiths, if we're looking for users, and return it. But let's go ahead and say we do something like, I want to get the average age for every user in this database. Well, the query router will go down and pass the same query to all 4 of them. So instead of waiting on one computer to process, a million records, you now have 4 computers, each processing 250,000 records. When they get their data, they'll pass it up to the query router. And the query router, like I said, doesn't really need a lot of disk space, but it needs memory, because it'll do the final computation to say, okay, well, I have 4 query results that round up to here. I'll do the final result and then return it to the application. So theoretically, you're processing data at 4 times the speed as if you were using a single server. Theoretically, it doesn't always work out that way. But the point is, you can add as many shards, and each one is called a shard, as you want. So maybe your data isn't spread among 4 servers. Maybe it's spread among 10 servers with 10% of the data on each server. Maybe it's spread among 100 servers with 1% of your data on each server. You can do it any way you want. MongoDB will auto-shard your data. What that means is you will pick something called a shard key. And a shard key is just a field that every document in a collection is required to have. And when you go ahead and pick that shard key, if it's last name, then what it'll say is we'll start by putting all the A's over here, the B's over here, the C's over here, the D's over here, and it auto divides it. So there's approximately 25% on each of the servers, an equal amount. You can also perhaps do something like use a hash. You can also go ahead and say maybe we'll use their email address or their phone number or their username. It really doesn't matter what you use as a shard key. Just that key is what's used to divide your data among multiple servers. So that's what sharding is, and this is called horizontal scalability. The next thing I want to talk about is replication. Now, each one of these, even though they're in a cluster, and the word cluster means it's a group of computers that act as one. So when your application goes through, makes a call to the query router, everything below the query router, although it's whatever, 12 machines at this point, 4 across, 3 down, plus the query router, 13 machines, the application doesn't see any of that. It says, I'm talking to you. I don't care what goes on in the background here. Just get the data, make the update, make the insert, whatever it is, and return to me. So all of these, from query router down, are acting as one machine. That's called a cluster. Okay. So for all the primary ones, each one is technically its own database. And with each of them, if your data is very important or it's too big to back up, if you can imagine something like Google that has multiple petabytes of information, exactly where can you even back that up to? I know I bought a 5 terabyte hard drive last month, but still, 5 terabytes, I would need 20 of them to equal 1 petabyte. So as you can see, where do we put it all? So what they can do is take your primary data and set up multiple. And you can set up 1, 2, you can set up a third, a fourth. There's no real set, but these are called, basically it's called a replica group, because every time we do an update to the primary, whether it's instant or it takes a few seconds, and there are settings on this, this data travels down to all the secondaries. So now you have a copy. So imagine now this primary, something goes wrong. Maybe someone ran across the carpet and gave your computer a shock. What can happen is these two will realize that the primary's gone, and the query router also realizes that this is not responding. They'll have a conversation, and they do what's actually called an election. The two secondaries, and the query router have a vote of who's the new primary. For simplicity, let's say it's this person, this database here. This one becomes the new primary. It takes its place. The data keeps running, so we have performance. Now, when the database administrator has time, he comes in, fixes the primary, and reissues it back as a secondary, and it will catch up and mirror the other systems. So overall, this is a bulletproof type of system and provides a huge amount of performance for large amounts of data and high demand databases. Obviously, I wouldn't set this up for a mom and pop shop who's selling, bars of soap or bicycles, but if you're selling something like a Walmart or a Target Online or an Amazon, this type of setup is what you need to keep your data, again, always backed up, always available, and have very little downtime. Here's another look at how to set up a shard as opposed to a single collection. So the idea here is that I have 5 billion documents in this one database, so it's huge, but I'm getting poor performance. What we can do is say, well, let's create 5 shards, so 5 different servers with MongoDB installed, and put 1 billion records on each one through some type of shard key. And then, because this data is really important, anytime there's an update to any one of these, we will replicate those changes down to those other servers. So again, one server becomes 1, 2, 3, 4, 5 times 3, it becomes 15 servers. Now, obviously right off the bat, you're like, well, 15 servers sounds much more expensive than one server. Yes, but this server is a single point of failure. On top of that, in 5 years or 3 years, when this server is too slow, you need to replace this server and do a big migration over which is probably going to mean some type of downtime. Over here, this server is 2-3 years out of date and things start going slow. That's great. I can add on another shard here and eventually expire that as I need to. So there is a way of entering in new shards and expiring old shards, but the truth is you can just keep adding shards, and these servers don't need to have the capacity or the cost of this server. Obviously, if I have 5 billion documents on one server handling 1,000 transactions per second, well, I need to go ahead and throw in whatever, 256 gigs of RAM and the super high octane processor out there and all the other fast stuff. These don't need to be nearly as tuned. So maybe while this server is a $50,000 server, each one of these 15 servers are $1,500 servers. So you can see how that could balance out, and this gives you a lot more stability in replication. Now, for replication, we're going to go ahead and actually set up replication outside of your VirtualBox. So there's another document attached called, let's see, ADB replication.txt. The next video will follow along with that on how to set up replication, and we will be setting up replication directly on your Mac. So please continue and follow along in that video.